So guys, let's look at the graph of phi here. It's going to be 1/3 secant of 1/4 x plus 1. So how should we start graphing this? Help me remember. Because on Monday you're going to take your first little graphing quiz. We'll have 40 unit circle calculations, 2 graphs.
Graph the cosine.
Graph the cosine. Regular cosine?
Yes. As a, what do you call it?
As a guide?
Yeah.
I don't think just regular cosine though, because that's going to be regular cosine, the transformed one. There we go. I like that. Gosh, nice. So I should graph this cosine, in other words, right? So first I want to think about the amplitude. This wave, this cosine wave, how high up and down? Just a little bit, right? It's not a very violent wave in this case. Our period, it's going to be, we start off with sine or cosine, we start off with 2 pi, and we divide by, if there's a thing in there, you divide by the thing, copy dot flip, 2 pi times 4 is 8 pi. So we're going to have this, we're going to have this, and then the plus 1's up 1, right? So we'll just remember to go up 1. Okay, so graphing that guy. Let's see over here, I'll try to leave lots of space. So we're going to be done at 8 pi. So this was a very long wave. I'll just put 8 pi. I don't know, I'll go 4 pi here, 8 pi there. I'll go back this way. So I'm just going to graph how many waves then? 2, right? 2 waves I've got on here. So we're going up and down just a wee bit, but I'm supposed to start up 1 for everything, right? Remember, always use your vertical shift first. So up 1, technically 4 pi is like 4 times 3, right? 4 times 3.14, so that's like 12. So if I drew this to scale, how far up is 1 going to be? Like that big, right? So let's not draw to scale because that's going to be way too hard to see. Let's just say arbitrarily 1 is right there, okay? So this is not to scale, but it's okay. All right, so we're going to go up and down, not 1 though, we're going to go up and down 1/3. Cosine starts up 1/3. Ends up 1/3 in the middle. This doesn't even look the same. Down 1/3, up 1/3, down 1/3. Cosine. Sorry, I don't have a better verb. Cosine. Remember, you want to draw these nice and neat, because if you don't, it's going to be a thought process, like a serious one, to figure out where your asymptotes go. Because where do I put my asymptotes? At the x-intercepts, right? Like where it crosses. It's hard to see the peaks and valleys here. It's easier to see the intercepts, so I like what you said, Jake. So if I drew my wave correctly, this should be right in the middle, because... Oh, I didn't go up 1, did I? How can I fix this without redrawing everything? I could relabel. That's kind of cheap though, isn't it? I don't want to redraw though. So what can we say? That this is really 0.
That's just as cheap though.
It is. It's gonna work though. I'll label it just to make sure we're clear. And this line then is what? 1. There we go. Now it's up 1. So what's the max of this wave if someone were to ask us what's the max of the cosine wave? Remember, we still haven't even done the secant, but the max of the cosine guide is how much? 4/3. And the min of the cosine guide down here? What's 1 minus 1/3? Just 2/3. But we don't even really care about that. I mean, you might see some stuff like that, though. We're going to stick with graphing those waves as well. For the secant, though, all we really care about is these little guys, right? What did we call these guys yesterday? Wannabe parabolas. Yeah, Noah's thing stuck. Yeah, I like that. Pseudo parabolas is my name, but I like Noah's. It's pretty sweet. Okay. So there is 1/3 secant of 1/4 x plus 1. All right. I should probably label one more thing. What do I not have labeled that I probably should label? the asymptotes. Where is this one?
2 pi.
Should be right in the middle at 2 pi, exactly, x. This one is negative 2 pi, negative 6 pi, and 6 pi over there. Okay, so there's a little warm-up, another example. So remember, when you're doing these graphs of trigonometric functions, there's really like 3 different kinds. The first one you learned was a wave. And the sine wave started in the middle, and the cosine wave started up. When we do more trig, you're going to realize that they're really just versions of each other. Why do we do them separately? Well, because sine is vertical, or opposite over hypotenuse, and cosine is horizontal. So there's reasons to do them separately, but they're kind of versions of each other too, okay? So that's really just one kind of graph. The other kind of graph we just did an example of was secant. Secant and cosecant, though, both go off their guides, and they're little pseudo-parabolas, the wannabes. Yeah? So that's the kind of shape they have. Then the third class of trig graphs is tangent, cotangent. Tangent we looked at yesterday, it looked like what?
A wannabe snake thing.
A wannabe snake thing, a wannabe x cubed function, right? So we'll compare it to x cubed in our calculator in a sec. I think we should do that. Well, let's do this one first. So this guy right here, and we'll practice this more, like I said, but I'm going to get it down as quick as you can. So tangent, sine starts in the middle, ends in the middle. Cosine starts up, ends up. Tangent
In the middle.
starts by straddling the x-axis, or the y-axis, excuse me. And its period's not 2 pi, its period is pi, but this one's been changed, so we better write that down. This guy has a period transformation. What's its period? You start with pi, and you divide by the thing in here. Tangent always starts with pi, not 2 pi. It's tangent. So you guys are correct. The period is 1. So should I put 1 and negative 1? This is probably the hardest part of tangent. I don't think it's too hard if you're awake. But 1 is the whole period. This is one cycle here. That means this width is supposed to be 1. If it's supposed to be 1 wide, how much is it this way? Yes. And how much is it this way? There we go. And notice on this example and a couple others we've done so far, do the x-axis always have to have pi's on them in Trigland? No. When you graph these in your calculator, do you guys ever remember since you're little learning about coordinates? Do they have pi in them usually?
No.
This is why you're able to graph trig functions on regular coordinates in Cartesian land. Okay? So, there's 1/2, there's 1/2. We're supposed to go 1 more. What's 1 more? 1.5 or 3/2. That's good enough. That's 2 cycles. Then tangent goes like this, right? Our little pseudo snake shape, you guys said. But negative is going to do what? Flip it down. So this graph is ironically very similar to cotangent. There's only really one difference. So let's graph plane cotangent of x. So cotangent of x, what's it look like? Remember, it's 1 over tangent. It's the reciprocal of tangent. Cotangent's pretty much exactly like tangent. I'm going to write 2 notes down. You guys, I gave you the domain and range of tangent yesterday. I'm guessing you can figure that out for this. I'm not going to write it down. Little problem solving for you to do. The only 2 differences I think you want to know is how do you start drawing it? When I start drawing tangent, the key thing to remember is both sides that it straddles. How's cotangent different from that? Yeah, it does exactly what I just did with this one. It flips it. Instead of going up all the way, always increasing, tangent's always increasing unless you flip it, like we flipped it. Yeah? Cotangent's always going to be decreasing, just like that flipped tangent over there. And instead of starting on both sides, instead of straddling, it just starts immediately at 0. Its period is the same as tangent, which makes sense because they're just reciprocals. So its period is what then? Yeah, 1 pi. They're the 2 oddballs out. They both get 1 pi. All 4 of the other ones have a period of 2 pi. Yep. This guy we're going to say starts, I don't know, at x equals 0. You could say starts in the first quadrant, whatever makes sense to you, yeah. And then we're going to always, unlike tangent, decrease. So it's going to look just like that one because we flipped that one. So here we go. And I said this was at pi, right? So the next one's going to be at 2 pi. If you wanted the x-intercepts of cotangent, plane cotangent, then one of them would be at half pi. Another one would be at 3/2 pi, 1.5 pi, etc. Okay, so there is plane cotangent of x.